All right, so let's get started. So in the next around 40 minutes, I'd like to give you a brief introduction about some more of the advanced patterns in TypeScript. So short introduction to myself. My name is Christian. I've been working as a software engineer for like the last 12 years. Started with Java back then, like 7 years ago. I switched over to more of a full stack role. So I've been working with TypeScript, JavaScript, and Angular all the time. So I also do some trainings on the side. I also really enjoy speaking and listen to other speakers talk. So if you have questions, just ask them all the time. You can just go to type.rocks/QA. There you can just enter your question. At the end of the talk, I will then answer all of them. And if it's too late because I'm a little bit short on time maybe, then I will answer them later. Or just go on type.rocks. There is my LinkedIn, my email, and everything where you can just send me a message if you have any question or want to talk. Yeah, let's start with the code. So this is we're in VS Code. So what we'll do first is we will talk about the mapped types. So what we can do here is, let's say we have an events type here. Now we say we have an add property and a remove property like this. Now let's say we want to have like a user actions object with an on method for each of these. So let's say we have an user actions like this, and we say this is of type on events. And now we say we want to have like an on add, which is a function, and a on remove, which is also just a function. Now, how could we create such a type? Well, basically we can easily say we have an on events here, and we say we have an on add, and we have an on remove like this. And we can see this works perfectly fine. But the problem here is that if I change something in the events, then I have no compile time error. If I go in there and say, okay, I have like a string here, we can see that I do not get an error in this user actions because it's not connected with each other. So how can we create like a mapped type from our existing one? Well, the first thing we do is we say, okay, we want to restrict this on events to only allow the keys of this events here. So only add, remove, or move. So what we do is we say here, event keys, for example, and we say key of events. This restricts this type to only have add, remove, or move as its string. So what the next thing what we do is we remove all the static types here. Now we use map types, so we can say we add the brackets and we say as a key, the key has to be in event keys. And the value basically is just any function. And now we can see that this on add does no longer work because we have to remove the on and we have to remove this too. But now we get an error because we have not added this specific property here, the move property. So this is where we get the compile time safety from TypeScript itself. So we add this just like this. And we can see our code compiles. The problem, of course, is we now have lost this on prefix and the uppercase first letter. So how can we fix this? We can just map over our keys. So we can say as, and then use template literals and say, okay, I want my key to have a prefix of on, and then I just put in my key with the template literal, and now we can see I could just change this and have it work like I like it. So, but now one more thing which is missing is the capitalized first letter. So what we can do is we can use a so-called intrinsic type function. This is the capitalize function from TypeScript. And we can just pass in our type. And we can see here, this is a so-called intrinsic function. What this means is it does just, the TypeScript file does this under the hood. So it does not really show it to you. By the way, for all of you who've taken photos, this is also on my GitHub, so you can just go to my website and you find all the code on my GitHub, so you don't have to like take pictures. Of course you can, but just that you can sit back and relax a little bit. So you can see here, now we have to uppercase, add, remove, and move. And as you now can see is we have created this new type, this on events type, by using the events as like its basic. And now we could, for example, change the remove to delete, and now we would have to change this here too. So this way we have like our base type and we have our derived map types which use it. So we have already seen here these template literals. So what we now can do is let's now talk about these template a little bit more. So let's say we have a type RGB CSS. We say this is just an alias for the string. Basically, it's just like a normal string. Now, what if we say we have a valid RGB, and we say this is an RGB CSS one, and we say RGB 1, 2, 3 like this, and this is basically a valid RGB CSS value. And now, if I say here invalid, and I remove one, I really would want this to throw a compile time error. So how can we do this? Well, basically, we can use template literals again. We can say, okay, we want to have an RGB as a prefix, and in there, I want to have a number, followed by a number, followed by a third one. And now we can see we get an error on line 6 because this is now not like in the structure we want the code to be. So, and this TypeScript is extremely clever about this. If I, for example, change this to 3a, this will also not compile because this is not a string. So I would have to change this to string. So like this, you can like narrow down your strings to even more specific ones. Now we can create with the mapped types and this template literals, create some really powerful helper types. So let me show you, let's say we want to create like such a margin padding type. We have a gap type here, which is either margin or it's padding. And now we say we have our gap position, which is either left or right or top or bottom. And now what you can do is we can combine them together with the template literals. We can say we have our gap CSS here, and now we can use backticks and can use create every possible permutation of these two types. So what we can do is we have our gap type, and then we have our gap position. And what this now creates is every possible combination of this margin padding and this left, right, top, bottom. So you don't have to create them all yourself manually, but you can let TypeScript do this for you. So of course, what you also want to have is only margin and padding without the suffix of left, right, and so on. So we just use a gap type like this and add a union type. So it's either gap type or anything else there. So now we can also create the values, so how we want the values to be. So we say we have our size type. This is either, for example, rem or pixel or percentage. And we can now say we have our size CSS. And this is now a template literal again with these backticks. We can say the prefix is a number, and then we have our size type like this. And now we can create a map type from these two and create this helper. So we can say we have our margin padding here. And what we now can do is we just say, okay, the key has to be in gap CSS and the value has to be size CSS. And now if we check, if we create such an object, let's see what the autocompletion gives us. We can see here we get every possible key which is allowed in this object because of this type. And for example, I use margin left. Then for example, if I use one rem, this works fine here, but if I, for example, remove one letter, then we can see we get an error. So now you maybe have seen that on line 17 we get an error. Why? Because these map types tell TypeScript, listen, if we create such an object, we have to create every possible property in there. And so if you don't want to add every possible margin and padding one, we just have to add a question mark to tell TypeScript it's okay if we don't add all the properties. So this is like basically how you can work with template literals. So now let's talk a little bit about a specific type in TypeScript, the so-called never type. So that I can show you something about the never type, we have to talk a little bit about conditional types. You maybe have already worked with this. Let's say we have a Boolean or never type, let's call it like this. And conditional type always takes a generic type. So it takes a type, it's like a pure function which takes something and returns something to you. So we pass in any possible type here. And now we can say, okay, if t extends Boolean, and this means if t is a subtype of Boolean or if it satisfies this constraint of a Boolean, in this case, we just return Boolean, otherwise we return never. Now, let me show you what this returns for us. So if I, for example, put in a string, then we can see here that we receive never, because this is not a Boolean, of course. If I pass in true, we can see that we get a Boolean back, because true is like a subtype of Boolean. Now, but how can this never type really be useful? Well, let me show you. So let's say we have a hello here, and let's call this hello box. Now, this of course is a string, right? So if I would say, okay, this is of type never, I would get an error, because if we check it, we can see that we cannot assign string to never. Now, we all know how to fix this. We go in there and pass in as any. The problem here is that this is still not working, because you can't even assign any to never. You can think of it like any is like on its own type hierarchy at the top, and the never type isn't in this hierarchy. It's completely on its own. So you can only assign something which has the type never to never. So you can't assign it to anything else. But how is this helpful? Well, let me show you. So let's say we have a function here, and let's call this fail on empty string. We pass it in an input. By the way, this annotation is just a plugin I've written so that you can immediately run your code in your editor without having to use console logs. So now we can see here, if the input length is not set, then we want to throw an error. So we say throw new error, and we pass in here input is empty. So of course we could call this with an empty string. We run it, and we can see here we get an error because the message, the input is empty. Now, but we really would want to have a check here from TypeScript. This here, of course, is a JavaScript error because we have thrown an error, so the code run. But we want to stop this from even happening. And this is where we can use basically the never type. So what we can say is, let's create a type here, no empty string. We pass it in a t, and we say, okay, if t is exactly an empty string, in this case, return never, otherwise return t itself. Now, let's use this in our fail on empty string function. What we now can do is we pass this in as a generic type, and we say, okay, this has to be a string. We can't pass in anything which is not a string. But now here, instead of passing in a pure string, we pass in our type. And now we can see something interesting happen. Line 11 does no longer compile because it tells you tried to assign a string to never. Now, this maybe looks a little bit strange, but let's backtrack why this happens. So we have this empty string here, right? This empty string is this t here, which we pass into our noEmptyString function. This now checks, okay, it's exactly an empty string. I resolve to never. So basically what this does is, this resolves to never. And we try here to send a string to the never type, which is not allowed to do. So basically this stops you from adding an empty string. So if I change this to something else, we can see this compiles, and I can run it. So maybe this is not something you do daily, but now I will show you something which I think is really important to have compile time and runtime safety. So let's say we have a location here, and this is either, let's call Zurich, or let's say Oslo. Now, let's say we have a function here, get country for location. And now we have our input here, which is the location we want to pass in, and we return our string. Now, everything I will show you you can of course also do with if-else, but I will show you this with the switch statement. So we pass in our location. So let's say we have our case for Zurich, and we return here Switzerland. Now the problem here is we can't even run this code because the TypeScript compiler tells you, well, you have told that the return type is a string, but we have here this Oslo branch, and you have not covered this, so if you run this code with Oslo, you will get undefined, and this is not allowed. Okay, so we add this, we add Oslo in here, and we return Norway, and we can see TypeScript is satisfied, so I can now run get country for location, for example, with Zurich, and we can see I get the result. So, but now the problem is, let's say somebody passes into your function something which is, for example, of type any, Or for example, you're developing a library and somebody from JavaScript is calling this and he does not have like JS docs. So the problem here could be somebody passes in like the string Paris and he passes it in basically like this because he's using JavaScript. Now, if we check here the result, it's undefined because this does not match any of the branches. So to fix this, you will add like a runtime safety check. You say, okay, in default, we say throw new error, and we say, well, the location is not known. Now, when we run this, we can see, okay, we get an error, all fine. Now, the problem is if we go back into TypeScript and we say, okay, yeah, well, but I want to support here Paris, and I forget to add this branch here, I no longer get an error message telling me, hey, you have not covered this case, because TypeScript tells, well, maybe if somebody calls it with Paris, you want to throw an error. So, but now let's see how we can fix this, how we can have the runtime and the compile time safety. So what you can do in the default cases, you just say you create a new variable. I call this variable mostly exhaustive, but you can call this anything you like. And the important part is you say this is of type never. And then what you do is you assign the variable you pass in here to this type. And now we get an error because you tried to assign a string to never. Because TypeScript is extremely clever about this. It sees, okay, there is this Paris, which is not covered in the branches, so location here has to be Paris, and you cannot assign Paris to never because it's a string. Now, this already works, and if I change this here and add Paris, and I say return France, we can see the error goes away. So you have compile time and runtime safety. Now, many told me, yeah, well, but now I have this variable, which is unused. And yes, you can remove this, and with recent TypeScript versions, you can use the satisfies keyword. So you can say location satisfies never here. And what this basically does, it tells, listen, at this point, location has to satisfy the constraint of never. So currently it does, but if I remove, for example, the Oslo branch, we get an error again. So this way we have the compile time safety, but also the runtime safety, because I always think that like in important parts of your code, you should always also think about runtime safety first, because all the types will go away during compile time, and of course you can trick TypeScript in basically thinking you passed in anything you like. So this is like how you can use it basically also with if. So you could use this with if else, and in the else case, you would then use this again. So, but let's now talk a little bit about another keyword besides satisfies. Let's talk about the infer keyword. So let's see how TypeScript itself uses this. So first let's create a function, let's create a simple function, an add function, and we return a number. We return a plus b. Now, I want to get the return type of this function. Now what I can do is, let's say add return here, I can say type of add. Now what I can do here, if I check the type here, we can see that this returns the exact type, because in TypeScript this not just returns like function or object like in JavaScript, but you see the explicit type. Now, but we only want to have the return type here. What you can do is we can use return type, pass in our type, and we get back the real number, the return type. Now, but let's see how TypeScript does this, and let's create our own return type. So let's say we have our type here, voxed return, we pass in a t, and we say, okay, as long as t is in the shape of a function which has any amount of arguments, we do not really care. And if it returns anything, in this case, to start with, just return any. Otherwise, return never, because we're not interested in this. So let's change this to boxed return. And you can already see it just returns any, of course, because we told TypeScript if it's a function, return any. Now, how can we get the specific part of this type? We can use infer. Basically, you can use the infer keyword everywhere in every extends clause. So what you can say here is, okay, in the case that t extends a function, we can say infer and then save the value in a variable, like in R in this case, and then just return it. And we can see now we get the number back. So we can also change this, for example, to string. We can see we get back a string. Now, TypeScript also uses infer heavily on to create these generic types it does. So we will also use this right now to talk a little bit about recursion. So you also can, of course, do recursion in any language, so of course also in TypeScript. So let me show you how TypeScript itself uses recursion. So let's say we have a nested promise. And this is a promise inside a promise, inside a promise. And let's say there is the string type. Now we want to extract this promise. How can we do this? We can say awaited. And if we check the result here, we can see we get back the real type. So how TypeScript does this basically is it just calls this generic function, this generic type with the inner type as long as it still finds a promise. As soon as it finds something which isn't a promise, it just returns it. So, but let me show you how we can do this. Let's create our own one. We call this unwrap array. Now, let's say we have our t in there, which can be anything. And now we have to think about how can we recursively call this inner array. So let's say we have like this, let's call this nested array, and we have an array inside an array inside an array. And let's say there is like a Boolean in there. Now, if we check the type here, we can see this is like a multidimensional array. And now what we can do is we say, okay, if t is an array, so if the type we pass in is an array, we just infer this inner type. So we infer the generic type of this array. So in the first loop, this is just like this array, then it goes one further, as long as and it does it as long as it has not found the real type. So as long as it does this, we just call unwrap array again with this inner type, otherwise we return it. Now let's just call this, and as you now can see, if we check this, we can see we get the Boolean back, because it's like this is like the simple way of doing recursion, because you just call your function as long as you have not found your result. As soon as have you found something which you want to return it immediately. So, but now what's even cooler is if you not just recursively call a function and return like the first object you found, but if you just create your own like type from it. So let me show you how we can do this. So let's say we have a type here. Let's call this RGB tuple. And this is fixed length array. So tuples are basically fixed length arrays. So for example, if I have my RGB tuple here, and this is of type RGB tuple, and I say 1, 2, 3 here, this works perfectly fine. If I remove an element, I get an error because it only allows like 3 elements in it. Now, just a quick side note for everyone using tuples, you can still use push or pop on it. So to stop this from being allowed in TypeScript, just add read only to it, and this way we can see that we have no longer the possibility to call this. So, but now let's say we want to have like an RGB tuple with 4 elements. Now what would you have to do? You would have to copy this, and you would have to say, okay, it's either 3 or 4. And let's say you want to have a tuple with 3, 5, or 10 elements, or like a tuple with 50 elements or something like this. Then you would have to like count them manually and create them, and it's really error prone. Now, wouldn't it be nice if there was like a type, let's call this tuple, where you can just pass in the length of the tuple you want and the type of the elements you want to allow in there? Well, we can see that TypeScript does not provide this, so we have to do this ourselves. So let's see how we can do this. We can always think about how we do this, because how would we do this in using pseudocode? So for example, if you have a function, a recursive function, the first element would be the length we want our array to be, our fixed length array to be. The second one would be the type. And now the third element is like this array we will build. So each iteration will add 1 element to this tuple array, and as soon as it has the length of the array we want, it will just return the result. So what we have to do is, let's call this ec for accumulator, and we tell TypeScript, listen, this is an array type, and we only allow in there these types we have defined. Okay, so now what we would have to do is we would have to everywhere use it as an empty array to start with, but we can of course do this easily by adding a default value so that we don't have to. Now of course this does nothing because we just said return any. But now let's implement this. So the first thing we do is we have to think about what is the exit condition. Where do we want to stop it from running and return our accumulated array? Well, basically, we can say, okay, as soon as the length extends, and now we have to think about, okay, how can I get the length of this array? Well, I just use length because TypeScript knows, okay, this is an array, so it has to have like a length property because TypeScript somehow has to know how long is this type array, because here when we have created this with 3 elements, it also had to know how many elements we want to allow in there. So as soon as the length here extends the length, we just say, okay, that's enough, and we return our accumulated value. Otherwise, what we do is, well, let's call tuple just again recursively. We pass in the length we already had, the type we already had, and now we have to add one more element to our existing array. Now, how do we do this? We can't use like egg.push because it's just like a recursive call. We just create a new array, spread our existing ones into it, and add a new type. And now we can see we get no more errors, so let's check the result here. We can see this has created for us a fixed length array tuple of 3 elements. Now I can of course change this to 4. We can see here it creates one with 4 elements. But the cool part about this is I can say 3 or 4. And as we can see, it creates one with 3 elements and with 4 elements. Now we can of course also say, well, I want to have number or string in there. Now if we check this, we can see it creates every possible combination. And the last thing, which is the read-only, is missing here. So what we do is, before we return it, we just add the read-only type here. We check it and we can see everything is now read-only again. So of course this is like a really specific case, but you can do this with basically anything. For example, if you have like a tree structure with like you can define how many entries a tree can have, or what the depth of the tree could be. Basically, you can anything which can be done recursively, which is basically anything, can be done with the TypeScript. The only like restriction is that you have to stop at 999, because as soon as you change here to 1000, then TypeScript will tell you, this is too much, we can't go even further. So it's like a hard stop, so that TypeScript, because it maybe is indefinitely deep. But I really like this approach because you have to create it once and then can just reuse it. So now we're already at the last topic, but I think this is really also for the ones of you who don't really like such advanced types and don't think they should use this. I think the last one really everybody should give at least a try, because let me show you what I think. So let's say we have an email here, and this email is a string, and it's me at type.rocks, for example. Now let's say we have a function, and you want to send me an email, and I have an input here which is a string. Now I send here, say here console log send email to, and I have this input. Now of course I can just call this send email with a real email, and all is fine, and this works well. Now the problem here is, of course, that these primitives can't be like narrowed to a more specific one. So the problem is that, let's say I could also call this with totally not an email. Now the problem here is that I could check this in this send email, right? But I don't want like the send email to be to have to check every time, oh, is this really a valid email? I want to do this like outside and be sure that when I can call this function, then it's like a valid email. So what I could do is I could say, okay, I have a function is valid email. I pass in my input, and I have here my Boolean, which I return, and I say return input includes @. This is good enough for us right now. So what we could do is we say is valid email, we pass in our email, and in this case, we then, let's put this outside here. In this case, we can just call send email with the email. Now, the problem is, of course, that you still can call this send email function without this if check, right? But we don't want to put it inside because then it has like multiple things which this function has to do. And this is where we can use branded types. So let me show you. First, what we do is we create a type called email. And let's just say this is an alias for a string. Now, where do we really want it to be an email and not just a normal string? We want to have it here in email, in the send email. We only want to be allowed to pass in an email. Now, of course, nothing really changed because this is just an alias. For TypeScript, it's just a normal string. But we can do some more work. We can say, okay, this is valid email here. This does no longer just return a Boolean, but this is a so-called type guard. What this does is we can say input is email. Now, basically, what this does, a type guard is nothing else than it tells TypeScript, okay, the input you put into this function maybe is a string or maybe is an object with certain properties, but I know that when this returns to true, it has more properties in it. For example, you could say you put in an object which has the property A in it, and if this now here you could check for a property B, and you could say, okay, if this returns to true, then the input you have put in is not only has the A property, but also the B property. Now, but you have seen nothing really changed. I can still execute it. Nothing really happens. But now, like the branded type magic comes into play. What we do here is we say, okay, this email is a string and it's an object, and you can put in any variable you'd like. I like to call this brand, and as a value, I say this is just email so that I can check it easily. And now you can see something interesting happened here. Line 18 does no longer compile because if we check this, we can see that string is not assignable to the type email. Now, why is this? Well, the funny thing is that this check here, this still compiles. So if I call it inside this is valid email, it still runs. Because in here we have this type guard. We basically tell TypeScript, yeah, the thing we pass in, this is a string, but it's also like this object with this property. But of course it's not. But we just trick TypeScript into thinking that. So, and the cool part about this is that in here, we can check here is just a normal string. But in here, we can see that it's like casted to an email. And now you maybe think, well, why is this useful? Because this is just still a normal string. You can work with this like with a normal string. If I check here for the properties on this is like it's a normal string which you can pass around, for example, to a function which only takes a string as a parameter. So for example, if I have here a function that's called trim, which takes a string in there, I can just call trim with my email like this. So you can see this like you don't have to like create a wrapper object, for example, like for an email wrapper object. For example, if you would do this in Java, then you don't have to create like a class for an email. Like in TypeScript, you can only say, okay, my primitives are still primitives, but you can be sure that if this is an email here, if I say I want to put in an email, in here you don't have to check the string again, because you can see, okay, this has to be a valid email. So, of course, you are not restricted to string. You can also have like number, for example, where you check if it's a positive number, or you could say a UUID or like a phone number, which has to have a certain shape. So this way you can have everywhere your branded types, your primitives, without having to wrap them into like objects. So, but now before we end, this is like a type guard, but there are also like asserts. Well, when might they be useful? So we say assert here, and we say, okay, we assert that the input here is an email. Now we see this does not return anything because we have to check that the input includes an @ sign. So if this does not, we throw an error, not an email. Now, when can you use this? You can now say, okay, we say here assert valid email. We don't have to use the if here, because now we can see that everything which comes after this assert valid email, knows that this email is really this in this certain shape. And this is especially helpful. Let's think about if you have an HTTP REST server and you receive data from your backend. And then you receive it, for example, as you receive a property called email. And then in there, you can just say, okay, when I receive it, I just call assert valid email. And after this code, after the request response comes into your system, you can be sure that after this check was done, this string is always an email, and you can just pass it around as an email and can be sure that it would not pass this check if it was not like valid or in the shape you want it to be. So I really like this. I use this a lot. For example, also we have like special IDs, or we have special like numbers like SV numbers in our, for example, in the insurance company I work currently. It's really easy to pass these around without having to check all the time, oh, what kind of string this really is. All right, so this is already it with the branded types. So before we now end, I'd like to give you maybe a little bit of a shock about what you could do with the types. So this is also on the GitHub. You can just check it out. It maybe looks a little bit strange at first, but if you like get a little bit into it, then it's not that hard anymore. So what it does is basically it is like this no empty string function, but like on steroids, because you can put in an arithmetic expression and it checks if it's a valid one. If so, it compiles, otherwise it does not. So for example, you can see here the mismatched brackets, or for example, if I remove this bracket here, we can see again an error. So in there, everything was done with all the things we have seen today. So we have worked with map types, template literals, never types. Also infer was used heavily, and it's really cool what you can do with infer, but I did not want to like scare you, so I hold it a little bit easier. So also heavily I used recursion. The only thing not in there are like branded types. All right, so now let's go back to the presentation. So before we go to the question, just a quick advertisement for me. So what we have seen, this is like the TypeScript worksheet is a plugin for VS Code. If you're using VS Code and you're using TypeScript and you want to try it out, it's like a free Quokka alternative to run your code in right inside your editor. It supports Spun, Node.js, Dino. It supports basically anything. You can also have your node modules in there, your code from other files. So if you want to just use it, give me feedback, what you like, what you don't like, because yeah, I think it might be helpful. It's free, by the way. It's not just like I want to sell you anything. So let's go to the questions. So let's check the questions here. Type system is amazing. Have you ever tried pushing the limits, compile by defining really complex types? Can it crash? Yeah, so it gets better basically every iteration, every new version is harder to crash, because it's like this recursion basically was prior to, I think, version 5, it only allowed like 40, like a depth of 40, recursion depth of 40, and now it allows like 1,000. And it really supports crazy complex stuff. Like you could also say, okay, if this T extends a certain shape, and you can say, okay, infer the head if it extends certain things. So it's extremely powerful, and it gets more powerful, I think, with each iteration. So no, I think before it crashes, it says to itself, it says that I can't handle this, so it will just stop itself from crashing. Yeah, I think he will go around question and with the mic. Maybe if somebody has a question, just raise your hand.
So if you have a question, please raise your hand and I will bring you the mic.
What happens if you change the value of the email? Is it then still an email, or is it back to a string?
You mean, yeah, no, it's, I have to check this.
Branded type.
Yeah. So if you change the value of it, no, because you are, if we check this, it should, it's an interesting idea, but I think it will stay the same, or maybe not, I don't know. Yeah, I think you cannot really change it because first it's a constant, but but the other one is, that this now is no longer like an email, because now you have reassigned it, and now TypeScript sees, okay, this is no longer an email, but it's now a string again, because you have like removed the object.
Yeah, okay, so I have to call the method again.
Yeah, yeah,
Okay.
you have to call this again, exactly. Yeah.
Thank you.
Yeah.
Yes, in one of your first examples with the margin or padding, would it be possible to further restrict it? Because if you only use padding or margin without the left top, you're able to provide 1, 2, 3, or 4 values, but not if you have the suffix.
Yeah.
Would this be possible?
Yeah, maybe you would have. Yeah, maybe you would then have to do something like create your own type and then say like it key is either in the first or the second one. But I am not really sure if this is possible, because these map types, like they have to have like one mapping over it, so you can't add like another. You can't add like something like 2 of them in there, because it's like at runtime it will then crash. So I don't really think it's possible to do this with one single type. You would have, for example, create margin padding without position type. But I think, yeah, this would be possible.
Do we have some more questions, please?
Can you please repeat why you had to add this brand property in the branded type?
Yeah, because otherwise, if you check this here, if I don't add this, then it's just like a normal type for TypeScript. It's not a normal string for TypeScript. As you can see here, I could now just say send email with email here, because now we can see that. Because here we say, okay, this is an email, but TypeScript will like reduce this and we'll see, okay, yeah, but this type here is just a string. So this is why it's like to really tell TypeScript.
So it's like an alias then?
Yeah, exactly.
Perfect. Do we have some more questions, please? Yeah.
It's really fast that it gets very complex, and when you have some junior developers in your team, it's probably hard for them to change your code or to understand all the types. Do you see there as some line somewhere where to stop to make more complex?
Yeah, I think it's really important that you keep it as simple as possible. What I think is important that you take, for example, if you have like this. Where we have this, let's call the tuple, for example, I think you should see these types as some kind like a library, basically. Like if you put in like Apache Commons or something like this, you do not really care what it does, as long as you do not have to like change it or handle it yourself. But of course, you have to always you have to check if it's worth it. I think what I really think is this branded types is really. This is something which is easily understandable, basically, because there are languages which support this stuff out of the box. But I think things like here with recursion, you have to really maybe also add some comments or have to check if you really need it or not. But of course, it can be really hard for juniors to do this. Absolutely.
Okay, so we have time for one last one.
Yeah. Or the other ones can just come over to me after the talk and then.
Thank you. So I've seen the recursion examples, and I'm wondering, I know that it's not possible to apply those to curried functions or partial application. Is there today with TypeScript 5, is it possible to infer values of curried functions?
Yeah, you can do this. After the last talk I did, somebody asked me exactly that, so that you can like check if a curry function which passes over to the next one, if this is like valid, and you can absolutely do this. Yeah.
Awesome.
Yeah.
Thanks.